So this is going to be a very different kind of exercise that was really enjoyable to go through. It's with Jens, Ludwig, Sophia, Pink, and Ashesh. And the exercise was, so much we've been talking about is the economy, but in the end, there are still people, and there are still people with the vagaries of people, and we still kind of will be interested in helping them. And if you think of behavioral economics, it has been the field that has been focused on what can we do to help understand the vagaries of what it means to be human and how we can, do a little better. And what I want to understand is how will that activity change with transformative AI, which I now know what it is. So I'm good, guys. Thanks. Yeah, I just needed 30 minutes. So what I want you to have in the back of your mind here, so I'm not subtweeting anybody, is nudge as sort of the canonical example of the sort of the pinnacle of which behavioral economics has reached. And what I'm going to do is I'm going to try and think about three things, pillars of behavioral economics. One of them is going to be the main gist of what I talk about, but the other two I think are going to be useful for completion. So if we start with nudge, I'd say this is probably the single most successful behavioral paper that I know of at some level from an application point of view. This is on defaults in 401ks. And it's still striking every time I see it. These are people who, when they joined a firm, this is what their retirement savings look like. And with one tiny change, which box you have to check, whether you have to check a box to sign up or whether you have to check a box to not sign up, you had this sort of immediate gain from about 86% from the beginning. People signed up for 401ks. This is striking in so many ways because people had tried to induce signups with subsidies and matches, and these effects are huge, and I think it launched this entire work. There is sort of an unfortunate dirty secret underneath all of this, which kind of came to the surface in the nudge literature, but which has kind of come to the surface on this work. Here's a paper by Bashir et al. In 2025 that just said, great, people signed up for 401ks. What happened to the rest of their portfolio? And it looked like they basically took on credit card debt. So while we were happy with signing them up for retirement savings, I don't think that we would have been happy at signing them up for retirement savings that is financed out of credit card debt.
Are they magnitudes comparable?
No, I think it's quite large, but I think they're big enough standard errors that, I wouldn't sit here and say the entire problem is this, but I also wouldn't sit here and say you should be happy with this is your credit card debt. And the reason I'm raising this is not to say defaulting in 401ks is a bad idea. It's to say there's a problem with this part of the literature, which is we have been developing things that help us nudge people, but we don't quite know whether when we do so we are improving welfare. I'll tell you another example. This is credit card disclosure, and if you pay this much, this was part of the Card Act. I don't know if you guys remember this. So this was thought, this is a really useful regulatory intervention to improve decisions, and I think some studies show that it was. But flash forward just a little bit, and once you have things on websites and bill pay comes on websites and no one opens things anymore, what does the Card Act mean? Well, it means when you go to choose an amount that's kind of buried here in this sort of, nobody ever gets to the disclosure part. Which raises a second question. Well, when markets have problems, we can regulate, but markets will respond. The third issue I'll raise is this is a book called Judgment Decision Making. It's the handbook of judgment decision making. Since I don't have much else to say, I'm just going to go through chapter by chapter. You can read what's here, heuristics and biases. Okay, here, now we're up to chapter 8, inside, outside. Twisted pair, counterfactual thinking and hindsight bias. This is a lot of heuristics and biases. Here, let's keep going. This is 26, behavioral. The reason I'm going through all this is there is one chapter in this 624-page book on a topic that you might have thought there'd be a lot on, debiasing. Isn't it curious that in your entire experience with behavioral economics, the entire literature is focused on taking biases as given and then, hey, people are going to be people, what are you going to do about that? And that's because this whole literature has sort of tried to say, let's change people, but has sort of concluded that debiasing interventions just don't work. That people are largely unfixable. We should focus on the decision, which is such a backstory that I think if you reflect on it, it's quite striking. It's like, oh, people can't be educated, people can't be changed. But it was arrived at an empirical thing. That Erik paper was one of the influential papers that said we've tried a lot of things. It hasn't been working. So decisions, markets, people. Decisions went through, and people we can't debias. I'm putting these together because I think all three of these sort of background problems in the field right now are actually prone to be solved by algorithms, and that AI is perfectly suited for it. And the reason I'm saying that is because I have to write a chapter on. No, I'm saying that because they all come from the same core problem. The same core problem that's giving rise to all three of these is because our capacity to intervene and do anything meaningful with people is very weak. We can change a default. We can send a message. We can change a card act disclosure. But that's about it. But if you think of, as in the agent examples you've seen all day, what has been the move forward? It has been the move to have algorithms that can much more richly and meaningfully interact with people, which opens up the design space tremendously. And I will try to argue that opening up a design space is going to fundamentally transform all three of these, and that we're going to be looking at a very different behavioral economics. So let's go back to nudging and we can improve welfare. Let me take something at the opposite extreme from 401ks just to illustrate how strong and how big the change could be. School choice. So there's a lot of literature that says if you have, your kid is going to join high school or middle school, and you have to pick which school, you have to enter one of these matching mechanisms, you have to rank it. People find this impossible. How would we nudge? Well, this problem makes clear the issue that was tacit in 401k. Why? What am I supposed to nudge people towards? The best school? What does that mean? Let's get everybody signed up for the best school. What's the best school? How do we know? More savings is obviously a good thing, or we've made the call that it is, but what's a better school? What's a better school choice? So what we need is a framework for decision making that kind of elucidates the problem. So I'll walk you through this fairly quickly. We have a decision D that's a binary choice. We have utility that people have as a function of their own characteristics and the characteristics of the choice. There's an optimal choice for them, given their utility function. But there's an actual choice. And so I'm going to summarize behavioral economics in one term. D of x minus D star of x. That's behavioral economics. Okay? And I'm going to summarize a ton of literature just through the lens of that one term. So what is reveal preference? I think we all know what that is. Epsilon is 0. That's what it is. That's what we say. It's great. What is nudging? Actually, nudging is also a very simple assumption on epsilon. It's saying the sign of epsilon is known and fixed across all people. Up is up. More savings is good. More vaccines is good. Great. Let's go further. What's a recommender system? Because we build recommender systems. A recommender system is the assumption that the expectation of epsilon is 0, so that if I can predict your choice, which is what a recommender does, predicted choice is actually the right choice. That's a recommender system. So in some sense, a bunch of stuff falls into these, but interestingly, none of these suit the school choice thing. I wouldn't want you to take my choices as given. I don't know what the right sign is, and certainly don't give me the choice you think I'm going to make. Which is, what is that doing? I think this is what comes closest. If you say, well, you may not know, your preferences are homogeneous, and based on observables, or some people who do know, maybe we can make it work. But it kind of is, it'd be a stretch. So what do we need? We need a way to acknowledge some facts that I think are true. People's utility differs and is not fully observable. This is the part where we may have some disagreement, because in the last thing we talked a little bit about, could you communicate your preferences fully, etc. I'm going to be operating the assumption that you cannot fully communicate your preferences in this case. Great. But we need to acknowledge that at the same time, reveal preference doesn't hold. There's actual error here. So we need a way to reduce error while appreciating its inscrutability at some level, the inscrutability of utility. Here's a proto-example of an intervention. This is by Hastings and Weinstein. I'm going to call it a proto-example. What they did was they just took a website and they just summarized the school choice options into a much simpler example. And they have a proxy of whether it improved choice by saying the set of people who just stuck with the default went down. So people made more active choices. They felt more comfortable choosing. But it's a proto thing because you've got to now imagine, surely, with all the chatbots we have, with all of the capabilities we have to discuss, we ought to be able to design an intervention that can talk to the person. I said, talk to me. I don't know why. Maybe I'm lonely. I'm learning a lot about myself today. Must help me think through the decision and then come to a choice. So ideally, it's not hard to imagine that in the future, in the not too far future, we could have something that has the ability to help me reason through my confusion and map my preferences, which remain private information, to this choice set. The challenge here is what would count as success? How would we know if this algorithm has done a good job? What would count as success is, I think, as we look forward, the key challenge of sort of, let's call it algorithmic behavioral economics. With nudging, we know which way is up, or rather, Bernheim and others would say we assert which way is up. But we lack such a metric here that we don't know, and we need a tangible framework. So what we're proposing is there's a notion from Rawls called reflective equilibrium, which I think is very helpful here. And the idea is, imagine if a person could or were to process all the information available to them, available at the time, not to the future, not imagining hindsight bias, what I learned, but at the time. What decision would they get? And the key is you want a decision that results from that process or get close to it. You don't need them to go through that process. In fact, the ideal thing is to get to that decision without me having to do anything. That's the notion of reflective equilibrium. The key challenge of reflective equilibrium is figuring out how to make it tangible and how to make it measurable. But I think there are ways. For example, we make one proposal, but I think the field will start to find other ways. We think of it as stability of behavior. If you're at reflective equilibrium, one property of reflective equilibrium was were I to present you with some information that was in that set, it really ought not to change your behavior. You said, yes, I already know that. If you take this definition, you'll notice how I think the default in 401ks could actually fail the reflective equilibrium concept. Because it could be, if you took the results of Bashir seriously, it could say, oh wait, would there be that much less money in my paycheck? Oh, well that's bad. And you notice that failure would be the reflection of the fact that they are inadvertently borrowing from debt in other places. So I think once we realize that there's a whole amount of need for reflective equilibrium, we'll also realize there's a pragmatic need for it, which is decisions are not isolated. If people need to make other decisions that are complementary with these, there's value to get to reflective equilibrium. Great. So for this bit, let me conclude by saying I think algorithms can play a big role here in promoting reflective equilibria. I've written down 3 examples here. In the paper, we try to talk about a few more. But one is there are many inputs that go into a decision that we can use data to help predict and transmit to people. For example, how well will my child do in a harder math class? Or how much more income growth can I expect? Or there's a lot of data we have that could inform every kind of decision. And that is something that can be promoted to people. A second thing algorithms can do is they can present many points of view. So when you're thinking about stuff, it'd be helpful for someone to say, hey, lots of people end up regretting saving, under-saving. Here are some testimonials from people who are older. There's a lot algorithms can do, which is play back information from the world. The third and possibly most important thing they can do, as Abhishek had kind of pointed out to us when he read a draft, is that algorithms can screen through a large number of options. And that is a very valuable activity. That is, in an ideal recommender system, it would get you to the option that is the best for you without you having to do any of that work. Great. So that, I hope, gives a sense of what I meant by our interventions are not smart. Right now, the behavioral paradigm is stuck in a very small world. Let me take that idea and blow it up a little bit. Let me go back to markets, and will markets respond? So this is a canonical example of obfuscation. Here are 2 credit card payments, annual fee, 0%, intro APR. Having to look through this is exactly the kind of obfuscation that markets are good at creating equilibrium around. They're fantastic. I mean, they're better at getting me confused than I am at getting my students confused, so I'm a little jealous. Now, if we just took not future AI, but just took tech right now, actually, I was surprised. We did this with ChatGPT. I was quite surprised at how good it is at just clarifying for you and going through the obfuscation. This is just a summary of the 2 credit card offers, and it was actually quite accurate. And it does the analysis. It says best for, but it gives you where the warnings are. After the first, you still owe, and it gives you a sense of you might have missed the pay later part. So there's quite a bit of processing that the summarization literature can do. Here's another one. This is an amazing paper from some former student of mine on bail. If you get arrested, you might want to pay attention, Ajay. If you get arrested, you'll get this bail summons notice. And as you can see, this is impossible to understand. So what this paper did was it worked with the city of New York to rewrite this bail summons notice in a way that was a bit more easy to understand. And they showed these pretty striking effects. 7 percentage points where the consequence is being arrested, because that's what a failure to appear is. Now you've committed a crime. Before you hadn't committed a crime, you're just showing up, but failure to appear is a crime, and now you're screwed. Is quite a lot thing for just like changing the printing on a form. But if we took the same form and just literally gave it to one of the language models and said, can you just rewrite this for me? It actually writes it as simple or even simpler than their rewrite automatically. I'll just add a footnote to this. The other part of their intervention was nothing more than send them a reminder on that date. And that had an even bigger effect. But you can see how trivial it would be for an algorithm to summarize and then send you a reminder. Why is this so important? Because when we do simplification, when we do card boxes, we are in a static change. But if algorithms can do the simplification we try to do by hand, the equilibrium is now between market forces and algorithms, which is a very different market equilibrium. It's even better than equilibrium between market forces and regulators at some level. In fact, that's why this is called spam detectors. We're now closer to the spam problem than we are to anything else. But again, this pushes the question back, which is we must now understand the market demand for algorithms and agents and what will people want. All right. The final thing I'll do is the debiasing thing. So here I'll try to be fairly quickly. My impression had been for a long time this stuff is utterly not doable. People have done it. Lyric, other smart people have done it. You can get some effects in minor areas, but like it's hard to do at scale. Then there was this work on Becoming a Man. Becoming a Man is this program with 16-year-old kids, 14, 15-year-old kids in the south side of Chicago, 12-week program. And it was kind of just got together and like talked to them about stuff. This is amongst the highest risk youth in Chicago. And what you saw was quite large impacts on arrests 2 years out. And when you did it in Cook County detention, again, with another population, you saw quite big drops in rearrest rates, like extremely large. And these are like 14 months out. So this was a program that was debiasing at scale, at length, for quite a weird bias. So why does BAM work? To make a sense of why BAM works, I just want to go back and talk about why does any education work. I would argue it works because we do 3 things. We explain a concept, we illustrate a concept, and you practice it. And I would say, this is very precise data, that the ratio looks something like this. That in order to learn anything, a huge part of learning is just using and practicing and repeating. Now, we've solved this for calculus and algebra because you can do little practice problems. How do you solve this for a debiasing intervention? Well, BAM solved it for a debiasing intervention where what they did in the classroom sessions was not teach you about biases. It was just talk through what you did, what happened to you that week, and ask you, did any of the biases apply that you've learned? It's probably too high. It's like much lower than that, but that is what they did. But it's hard to do this at any sort of reasonable scale. And so what I would argue is algorithms are going to change this logic. This is a really interesting product. You guys should go look at this. It's called TeachFX. It just records teachers. The teacher records themselves. And then afterwards, it analyzes all of the stuff and starts giving feedback like, oh, you know, this is how many minutes of silence you had. You talked over students at this rate. Oh, you said you had a goal of wanting this, but you actually did this. That's just for teachers. That's like BAM on steroids. Algorithms, I think, will let us do that last piece of practicing at scale. It's zero-cost debriefing, practice on demand. And I think we'll break through this we can't seem to de-bias. So let me conclude here and say, what do we need from transformative AI? We kind of need new capabilities as thought partners, like the school choice thing. We need question asking, theory of mind. We need its ability to kind of implement stuff. We need to be able to expand existing summarization for adversarial contexts, which right now that's not really what they're optimized for, it's just summarization. And AI models need to identify concepts relative for me in situ. I'll conclude, since I did Bertrand Russell before, I'll do the other famous philosopher, Richard Thaler. Thaler has often said that behavioral economics should become obsolete because it should be all of economics. I kind of want to hope I've convinced you that I think algorithmic behavioral economics should become obsolete because it should become all of behavioral economics. I just don't see a world where there is a way to think about behavioral economics without algorithms. All right, thank you.
That's fine. Thank you so much. Thank you to the organizers for inviting me to be a part of this fun conference, and thank you to Sendhil and co-authors for writing this really interesting paper. Learned a lot, both about the history of behavioral economics, but also the unique and different ways in which algorithms could be used here. I think quite different than what we've talked about this morning. Seeing all those examples about different kinds of decisions where people make mistakes took me back about 30 years to when my dad was buying us a car. And I was really rooting for the one that we couldn't afford. That was really nice. But the one that we really should have been buying was this trusty old, as it was called, Maruti 800 back in the day. And my sense is the focus of this article is that a lot of people look like me back there, which is that we're buying sports cars on sunny days when instead we should be thinking about what actually our commute is like, etc. Right? And so have that in the back of your mind, right? If pension savings is not your jam. And what Sendhil and co-authors are really saying is, I think one way to really think about it is behavioral economics 1.0 has been a kind of a one-size-fits-all solution. Insofar as we can't go down to understanding the different preferences of people and why they might make these differences, make different judgments, instead we're going to be top-down and think about systematic biases that people make and try to fix it that way. Right? So think about nudges, think about changing designs of different forms, so on and so forth. The list is quite endless. But we had Thaler up there, people were skeptical of behavioral economics when it first came up. And in some ways, the success of behavioral economics has forgotten why people were skeptical about it in the first place, which is that people believed in the real preference. Right? So one way in which I think about this paper is trying to bring the economics back in behavioral economics, in the sense that how can we pay attention or how can we value heterogeneity in preferences while still understanding that people are imperfect. Right? So, and the solution to that has to be, at some deep level, customize algorithmic interventions. The other really interesting idea in this paper is this idea of reflective equilibrium, which is really quite new for me. And I think that's both kind of a contribution of the paper, but as I'll talk about, something that the field will really need to clarify and define. But one way in which I think about it is basically asking the decision maker about how comfortable they are with their decision when presented with alternate information. Exactly what was mentioned in the presentation. But precisely what that alternate information is, or precisely when that question is asked, or precisely what the other architectures under which the decision would be made, is still kind of left unspecified. But for now, imagine this Buddhist monk up there who's very comfortable with all of the life choices that they've made, and that's ideally where we would like all decision makers to get to. right? So as a goal, I think it's a really helpful goal for us to have as someone who studies people's decision making. Okay. We didn't get to talk about this, but one of the things behind in the model that was presented was different ways in which these errors could creep up. And they argue, which I completely agree with, is two ways in which these decisions errors could manifest is actually really helpful in carving out a role for algorithms. The first you can think about as input errors. And the second set of errors you can think about as processing errors. So input errors are basically, I simply did not pay attention to the fact that after 18 months, the interest rate on this credit card is going to go up. I simply didn't know that there's this third credit card out there that would dominate the other two that I'm choosing, so on and so forth, right? And so when I was choosing the car, I used this particular magazine, which is filled with pages and pages of data on everything from the cost of the car to its mileage to its horsepower and so on and so forth, right? And so I might make a wrong decision simply because I didn't internalize all of that information correctly. And as many of us have learned, algorithms are extremely good at doing that. On the other hand, the magazine also came up with this really helpful framework so that I can explicitly specify how important it was that the car would look great to my friends, as opposed to the fact that we could afford it. And here is where the heterogeneity of preferences would really come in. Right? For some people, that number would be high, and for others, that would be low. And so these kinds of tools, you've bought rent or buy tools, all kinds of tools that we use that help us be more systematic about all of this data and make sure that we're actually writing down what our preferences are before we come at a decision. Now, this is archaic, but surely algorithms could do much, much better in this process of helping us both understand ourselves and then take all of that data to arrive at decisions. And that's, in some ways, I think, one of the most helpful things in the paper is this mapping from these different kinds of biases to precisely how algorithms could help us. And I think we talked about that, so everything from summarizing and predicting how different, for example, a very complicated schedule of interest rates would translate into a difference in payments. To me, the really novel and interesting part is this second set of categories, which I think about as like before decision, during decision, and after decision. So you can think about how algorithms could basically be a helpful guide as you make those decisions, which is a very different model than being shaped by a nudge or a default even before I get to that decision, right? That's really the vision of behavioral economics 2.0, to summarize. I love many, many aspects of this, so I won't belabor it. But one way to think about it is really recenters the people and their agency while still acknowledging their biases, right? And so there's a nice line in the paper, which is sometimes we tend to ignore really big problems because we can't solve them. And this is definitely one of the big problems of the whole field that this paper is tackling head on, which I really like. I'm not going to talk about the first of these areas for improvement because, as was mentioned, I think the paper already deals with consideration set errors. In the version that I read, this idea that you can expand the field or expand the set of options wasn't central, but seems like that's been revised. But I want to talk about points 2 and 3 for a second. So we are talking here about transformative AI, and I think we all have different visions of what that is. But in my view, whatever mechanical transformative AI system we might have might transform, but might still face some of the challenges that current AI systems do in terms of everything from biases, the fact that they can only see the data that they have, and so on and so forth. It would be nicer for the field going forward to think about these AI systems as proxies, so human simulators or similar human experts of different types, rather than all-knowing oracles. Right? So you can imagine when you talk to a guide or an expert or advisor, they're much smarter than you, but they're also quote-unquote biased in their own way, and that's really helpful. Right? But that doesn't mean that that's the only perspective that you want. So how can we incorporate the heterogeneity of different preferences of the AI systems as we think about developing this behavioral economics 2.0. So rather than treat that as a monolith, we can actually think about different kinds of interventions, insofar as the systems themselves will have a lot of heterogeneity. Third point I'll make, this came up, going back to kind of what's first order versus not, this is a hypothesis I have. And it's something that, again, should be tested going forward. And we talked about this, I think, in Betsy's talk in the morning, which is part of the meaning that people get from decisions is the fact that they felt like they were at the wheel. And with nudges, my sense is that isn't really affected. We often have no idea that my savings rate is much higher because of a design decision someone else took. While at the extreme, we can imagine delegating all of our decisions through agents and making perfect decisions, but then not being proud of the choices that we've made. Right? So insofar as we think that this channel for owning your decisions is quite important, I think work on human-AI collaboration will think about how exactly you create that balance. More broadly, I think one of the more philosophical questions is, to what extent do we want to completely do away with this top-down interventionist behavioral economics 1.0 approach to a fully flexible one that prioritizes reflective equilibria versus the cases where some of this might actually be really still relevant? My hunch is that there will be a need for a balance. So we already talked about cases like conditions where there's externalities. Maybe there are situations where we do actually know the kinds of outcomes that we want, versus others where this kind of approach would work really well. Right? So insofar as algorithmic behavioral economics still has behavioral economics, a key question is to figure out what parts we want to retain versus what parts we want to improve on. The last thing is the way I would answer a lot of these questions, through maybe we don't like horse races anymore, but since that's the only model of science I have, is actually to compare different scenarios of decision making. And John was here in the room, and I've done some work on using AI as a simulator. So I think we actually want experiments with people. But this is from a paper of ours where we showed that AI simulators can do quite well in simulating lab experiments. And so we, in my group, set up a very simple experiment going back to the car scenario, right? And so we created different agents, and we told them, you're Harry, you really like status and prestige, and here are your two car choices, what are you going to choose? In one condition, we simply gave the agents a nudge. Right? So remember, when choosing a car, practicality is as important as status. While in the other, we had Sendhil and co-authors' vision of a helpful decision support guide who would constantly monitor what you're doing and then come in to intervene. So in that case, they would get a nudge saying, hey, I see that you're selecting the luxury car. Have you really thought about your decision? So this is one of the specific recommendations that you make in the paper. And at least in our simulations, what we found is that tends to perform much better than in the nudges. Right? And so I think lots more empirical work to be done in figuring out where that balance is, so that in the end, my dad did get the practical car. but if we had these tools, I think that debate would have been much shorter. Thank you so much.